Good morning. I'm here to present a risk forecast system for moored ships. My name is Liliana Pinheiro. I'm from the National Laboratory for Civil Engineering in Lisbon, Portugal, and I'm part of a team that is developing a forecast system for moored ships, and we have applied this to some ports in Portugal and in the Azorian Islands. The topics of my presentation will be an introduction, then I will present a case study. I will talk a little bit about the EcoMar Port project, who is financing this development. Then I will show you a little bit about the numerical modeling system, and then how we do the risk forecast system, and finally some comments about this work. The Azores archipelago is where our case study is located, in the middle of the North Atlantic Ocean. More specifically, in the central group of the 9 islands, we have the island of Pico. In this island, we have 2 ports where this system is implemented: São Roque do Pico port in the north coast of Pico Island and Madalena port on the west coast. So our case study is in Pico Islands. There are 2 main ports, as I said before. Pico is the second largest island in the Azores, and it's dominated by a 2,350 meters high volcano. The port of São Roque is the main commercial port of the island. It receives cargo ships as well as ferries. In the past few years, some big storms have passed through the Azores, and some accidents have taken place in these ports, namely in Madalena do Pico. We have the big storm in 2017, and the port structures were heavily damaged. Another accident that happened in January 2018. The ferry ship with passengers was grounded when entering the port due to heavy winds and waves. São Roque do Pico is a little bit more protected from the south and southwest more frequent storms, but this port has also been hit by some storms. Namely, in 2013, a big storm was hitting a cargo ship, preventing any port operations, and in 2014, a big accident when a mooring bollard broke loose and killed 1 passenger. So, over €500,000 were spent in replacing all 30-ton bollards by 50-ton bollards in all the Pico Islands ports, and over €300,000 were spent in improving port operation safety. Following all these accidents and events, there was a research project that was funded by the European Union, and LNEC was commissioned to develop 2 new forecast and warning systems for these 2 ports. This system aims to issue alerts when security is at risk. This is the structure of the Storms Alert system. It has 4 modules. The first module is for wave propagation. It uses a set of numerical models to forecast, predict, and propagate wave characteristics from the Atlantic Ocean until inside the port. The second module, the port operations module, uses numerical models as well to simulate the behavior of moored ships and to get mooring forces and ship movements. A third module does the risk assessment. So it evaluates the exceedance probability and the consequence of this exceedance, the exceedance of forces and movement thresholds. From this analysis, we can assess a risk level. And finally, we have the alert system, which is a web application where all this information is available to the public and to the port authorities. So we have a floating structure interaction model. It is based on solving the motion equations for a moored ship. So we have mass times acceleration, and we have the impulse response functions and the hydrostatic restitution. And from this side, we introduce the hydrodynamic response of a floating structure to waves. For this assessment, we use the WAMIT model. On the right-hand side of the equation, we have the external forces due to waves, and these forces are gathered using our wave propagation models. And finally, we have our what we want to determine, which are the forces in the mooring lines and in the fenders. For this assessment, we use the constitutive relations of the lines and the fenders. And finally, we also introduce the forces due to winds and currents. So the results of these equations are the ship movements and the forces. So this is an example of what the system produces in terms of graphics. We have the forecasts that come from the European Center, and then with the use of SWAN numerical model, we propagate this until the site that we wish. Finally, using DREAM's numerical model, we propagate these waves into the sheltered area of the port. So this is a finite element model, so we need to define all the mesh, the boundary conditions, and also the reflection conditions of the boundary. So here is a comparison with the wave buoy that we made to validate all these interlocking of models. And we can see here the wave buoy, the significant wave height, and then the significant wave height given to us by the numerical models, the green line. And in the last line we have the significant wave model where the ship is placed. So we need also to numerically simulate the ship's response. So we need to discretize the ship's hull into panels to use WAMIT. So this is an aspect of the ship paneling. In this case, we used 2,353 panels. From this, we get the forces over the frequency of the wave. After that, we define the mooring system with the force elongation relationships. And finally, we have some time series results of the motions of the moored ship. So this is a little animation of the motion of the ship under a certain condition. And you can see we have all the information, and with these results we can make a statistical analysis to see if the thresholds are or not. So with this information, we perform the risk evaluation, and we can issue warnings for the forces in the mooring lines. So we have 5 risk levels, from no danger to a maximum warning level, where loading and unloading operations are suspended. There's a high probability of breakage of mooring system elements, or infrastructures can be seriously damaged. So this is the red warning level. To conclude my presentation, I presented the system validation using historical data to ensure the system reliability. Some adjustments must still be made with the collaboration of the stakeholders in terms of defining threshold limits for the forces in the mooring lines and for the motions, and also to estimate the costs associated with the non-operational of the vessels. So we need to establish a well-documented consequence table. I would like to thank you for your attention, and I would like to thank all the participant entities that funded this research. And I leave you with this little video of Pico Island, so you can be interested in visiting if you want. Thank you very much for your attention.